Alright, so in this video we're going to do the second part of what I was discussing previously in the last video, and that is how do we find trig ratios of our common angles. And I would argue that the unit circle is by far the best way, and that's what I'd be using, especially when you get to Chapter 5 and Chapter 6. In Chapter 5 you're dealing with the identities. In Chapter 6 you're dealing with solving trigonometric equations, and that's especially when this will be very helpful to you. So with the unit circle, what you find as you do trigonometry, remember our radius was r, is it doesn't matter what the radius is, you'll always get the same answer for the trig ratios. And so why not use a number that's very easy to work with, like 1? Notice what happens if I want to find the cosine of theta on the unit circle. Well, cosine is adjacent, the adjacent side, which here would be x, over the hypotenuse, which is 1, and you get x. And so you can see that the value of x at this point is the cosine of theta. And similarly, the value of y is the sine of theta. So now let's go ahead and use the unit circle. Let's go ahead and move down. So it becomes very easy to find the sine or cosine or any of the other ratios for any of these angles that we've been working with. So if you want to find the sine of pi over 6, you go to pi over 6, and the sine is just the y value, which is a half. And cosine of 7 pi over 4, well, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, those are our key multiples of pi over 4 that we need to have memorized. But at that point there, cosine is the x value, which is the square root of 2 over 2. And what I wanted to say is you really need to get to know this first quadrant. And once you know the first quadrant, you could find any of these other angles. The only thing that's going to change is the signs. So like here, if you take this point and you go to the third quadrant, you have a similar point. The difference is x and y are both negative in this quadrant. Otherwise, it's the same point. It's 45 degrees from here to here and here to here, just like what we have here. All right, so let's go ahead and do some problems. We have sine of theta equals 0. So remember, sine is the y value of our point. We want to see where that y value is 0. Well, that happens here and also here. So at 0, and really in 360 degrees or 2 pi, there's really just one place, and that's at 0. If I put 2 pi, that's really just repeating, it's coterminal. So let's see, cosine of theta is -1. No, I'm sorry, I said that wrong. Our two answers are actually at 0 and 180. Or actually, we're going to use pi. Okay, let's go to cosine. Cosine of theta is -1. Well, for all these points, where is the x value? -1. Well, that happens right here. In fact, there's no point. Well, there's only one point where our x value is going to be -1. And that would be right here at pi. What about sine of theta equals a half? Well, the y value is a half. Well, that happens here and also here. Now, I wanted to show you something with this angle, or this point. If I put this triangle in here, what I want you to notice is the x value, square root of 3 over 2, is the longer side, and the y value is the smaller side, which is 1/2. You could actually do square root of 3 over 2, and you'll see that it's definitely bigger than 1/2. I think it's, oh goodness, I think it's like 0.8 something. But anyway, it's a bigger value. And so you can compare that to this point here, where you have a 60-degree angle here. Notice your x value is the smaller side of 1/2, and your y value is the longer value of square root of 3 over 2. All right, so anyway, sine is 1/2, or the y value is 1/2 here and here. So that's at pi over 6 and 5 pi over 6. Let's see, cosine of theta is negative square root of 2 over 2. So remember, that's our x value. Our x value is negative square root of 2 over 2. That happens here and here. So at 3 pi over 4, and also at 5 pi over 4. All right, on the next one, and keep in mind what we're finding here is the angle theta. All right, so tangent of theta is negative square root of 3. Now, what you find is that's going to occur at one of your angles that are multiple of either 30 degrees or 60 degrees, or pi over 6 or pi over 3. So we can see that we know tangent is negative when the signs of the points are opposite. So tangent's negative over here and also over here. And so to get negative square root of 3, that's either going to happen here or it's going to happen here. So let's just go ahead and check this out real quick. We know tangent of theta would equal sine, which is the square root of 3 over 2, over cosine, which is negative 1/2. And you can see that's square root of 3 over negative 1, or negative square root of 3. So we got lucky. Whoops, let me move that down just a tad. We got lucky there, and we got it on the first shot. And so this point, when we're at 2 pi over 3, that's one of our angles where the tangent is equal to negative square root of 3. To find the other one, we could actually go on the opposite side. See, it's going to have the same two values. The only difference is you'll have 1/2 and negative square root of 3 over 2, and that actually happens on the opposite side. And so that would be at, so again, notice they're the same numbers that you have here, just opposite signs. And so this will also happen at 5 pi over 3. All right, last one here, we have secant of theta is equal to negative square root of 2. I think the easiest way to tackle this one is if secant's negative square root of 2, then we know the cosine of theta is negative 1 over the square root of 2, which we normally write as negative square root of 2 over 2. So where is the cosine negative square root of 2 over 2? Well, remember cosine is the y value, and it needs to be negative. So that's going to happen here, and it's also going to happen here. So it's at 5 pi over 4 and 7 pi over 4. All right, that's going to be it for this video. If you have any questions or comments, let me know.